Welcome to BrainBites, a bite-sized neuroscience podcast aimed to inform you about the neuroscience world.
All in short, digestible episodes. This episode is brought to you by the Ascend program, advancing STEM community engagement through neuroscience discovery, with support from the Stiles Nicholson Foundation.
We're your hosts. I'm Dr. Melissa Borgen, and I'm a postdoctoral neuroscientist at the Scripps Research Institute in Florida.
And I'm Danny Nemeth, a PhD graduate student studying neuroimmunology.
Oh my God, Danny.
What?
I had the scariest Halloween scare of my life.
Oh my gosh, I'm shaking. What's going on?
My computer crashed, and I thought I lost all of my data.
Oh my.
It turned out okay. I have a backup.
Oh, good. Oh, good. Oh, good. I was scared there for a second.
That was scarier than any scary movie, zombie monster I could possibly think of.
Oh, yeah. That's years of work.
Well, thankfully, we have automatic backups.
Oh, perfect. That was giving me the shivers and making my palms all sweaty just hearing about it.
Tell me about it. My sympathetic nervous system was lit up.
Oh, yeah, your sympathetic nervous system. This is a branch of your central nervous system. You have one branch of the parasympathetic, and the other branch is the sympathetic. The sympathetic is what is responsible for your flight or fight response.
And I had a freeze, and oh no.
Yeah, and freezing is part of the fight response, because you'll freeze and then figure out what you're going to do next. And you get all these symptoms when your fight or flight response is activated. One of them is sweating. Another one is your pupils will dilate. You'll have increased heart rate. And you're going to feel afraid.
Man, data analysis and doing science is apparently a very dangerous line of work.
Definitely very dangerous.
You know, it's interesting because this was a terrible experience, but I actually really like watching like scary movies and going on roller coasters, all things that are like legitimately scary and cause the same physical effect. Why is it so much fun to get scared?
Well, when your sympathetic nervous system is activated, you end up releasing a lot of adrenaline, and also you trigger other downstream molecules in your adrenal glands to produce cortisol, which is a stress hormone. And the combination of this adrenaline and cortisol will ultimately end up activating some dopaminergic signaling pathways.
Wait, so dopamine, like the yay, good stuff dopamine.
Exactly. And dopamine is a neurotransmitter that causes pleasure and happiness.
Huh. So I guess it's good to get scared. It feels good to get scared if you don't actually get hurt by the scary thing.
Exactly. Yeah. So when you're on a roller coaster and you're feeling really nervous, that's your sympathetic nervous system activating. But right when you know that you're going to be okay, then you feel good and you want to do it again. Huh.
So, yep, I'm just looking here. I just read a little something that says that even though like watching a scary movie or on a roller coaster, like our higher brain, our cortex knows that we're safe. We're intellectually aware that we are not in danger. But our sympathetic nervous system is still kicked into high gear. Then we get all of this dopamine and stuff. And so that's how we get the pleasure, that you get scared, but you're actually safe, and you know you're actually safe, but you still get kind of that benefit of a whole bunch of neurotransmitter rush.
Yeah, that's why we love roller coasters and we love scary movies and we go to haunted houses and we just want to feel that adrenaline rush that ends up converting into dopamine.
Huh. I wonder if there's a sense of accomplishment too. Like I remember being really scared of roller coasters when I was little, and then getting over that fear and going on them. I wonder how that affects the brain.
That's something really interesting to look into.
Well, you know, speaking of scary things, and it is Halloween, what are some of your favorite scary Halloween type movies?
Ooh, Halloween type movies. So I think my favorite of all time has to be zombie movies.
Oh, they're so scary. They actually give me nightmares.
Super scary. We all know of The Walking Dead, the TV show that is all about zombies, and then there's 28 Days Later, and then really the original Walking Dead, the
Dawn of the Dead?
Dawn of the Dead, yeah. There's Dawn
Night
of
the Living Dead.
Night of the Living Dead. That's the original zombie movie. And all of those are just so fascinating. And they're scary because it's a bunch of people coming at you and trying to eat your brains.
Yeah, I think that's kind of the most horrifying aspect, to think that, like, oh no, my mom could become a zombie.
Exactly. It's all your loved ones. And I wondered, whenever I'm watching those movies, can this happen in real life?
You know, it's an interesting question. The knee-jerk response scientist to me is like, no, of course not. But there are actually historically documented cases of zombies. And when I say zombies, it's not exactly like on the TV show where you have a rotting corpse coming back from a grave and coming out. But in the 60s, there was a man in Haiti named Clairvius Narcisse who was purportedly dead for 18 years and then showed back up in his village and said, hey, I remember being buried. I remember being dug up, and I've been basically held captive for 18 years and I escaped. And everyone thought he was a zombie because he was legally declared dead. And what people think happened is that he was actually poisoned. That it was likely a combination of something called tetrodotoxin, which is in pufferfish, and a poison that's part of the datura plant. And it causes a person to kind of appear dead or shuffling or hallucinate. It can, depending on the dosage of these things, it can kill you too. But they think that it suppressed his metabolism so far down that he appeared dead. And then this person who basically kidnapped him dug him up and revived him and then kept him drugged for 18 years to keep him prisoner.
Oh,
so,
wow.
not exactly how we think of the classic zombie, but by changing the way the brain functions with either damage or poisons, it can create the kind of classic shuffling gait, not really recognizing everybody kind of zombie.
Oh, wow. And it reminds me of being able to change behaviors in mice. And so the one behavior that zombies have that make them extremely scary is how aggressive they are. And that's what I find extremely scary about them, is that there's this brain-eating human or dead human that is so aggressive that it wants to just eat my brains out. And so scientists have been able to induce aggression in mice by injecting a specific virus into the hypothalamus of the mice and then giving a drug that will activate those neurons. And by activating those neurons in the hypothalamus, they can induce the mice to have hyperaggression.
Huh. That's really interesting.
And so it can kind of, be one of the symptoms or one of the behaviors of zombies that neuroscientists can replicate in the lab.
That's really interesting. So we can make mice hyperaggressive just by tweaking brain activity, and we can do this in a lab. Kind of makes me think of things that are observed in nature, where, like in 28 Days Later, the zombies, so to speak, were actually infected by a virus. And that's very similar to something that we observe in nature with rabies.
Exactly, yeah.
Yeah, rabies will cause animals to become extremely violent when they formerly weren't.
Exactly, yeah. And that hyperaggression is making my hair stand on edge.
Oh, your sympathetic nervous system's kicking
in.
One thing that I feel like we should discuss, because we both are really into zombie movies, and I feel like you and I both have strong feelings about this. Which of these zombie canons do you find most plausible?
So most plausible. So I want to start with least plausible, because whenever I watch Walking Dead, it makes me feel that, just understanding how biology works, that zombies should not be able to be alive for that long, for years on end, while they are also disintegrating, while they're decomposing.
Right. I mean, that's the whole premise, is that they died and then they're somehow reanimated, but they're still rotting.
Exactly. And so we're using our neuroscience knowledge. We know that there is the neuromuscular junction, which is the junction between your nervous system and your muscles. And if your muscles are rotting, then your nerves won't be able to activate those muscles, and you won't be able to walk or be able to chew or any of those things. So having a rotting corpse isn't really plausible for kind of a real life application.
Right. I mean, it's kind of the classic zombie trope too, like, Shaun of the Dead, destroy the head, then you take them out. So if these things are rotting actively, their nervous system is rotting too. So, destroying the casing isn't going to make a difference when the brain is soup.
Exactly. Yeah.
And I say this with love. I love these movies.
Oh yeah. But they're more fiction than science fiction.
Right. And I still stand by, in The Walking Dead, it's been several years at this point, and there have been many hard freezes. They would turn into goo.
Oh, yeah. Oh, yeah.
They would not
a bunch of
survive a
roadkill.
hard road freeze. Not even roadkill at that point. Like literally soup.
Yeah. Well, then also, so I guess most plausible is a movie that we've kind of brought up already is 28 Days Later. And they turned that into 28 Weeks Later, and I don't know how much farther they've gone. But like you said, those people are infected by a virus.
Right. They haven't died. They have become infected with a virus that's changed their brain function.
Exactly. And they called that the rage virus. And the scariest thing about that, once again, is the aggression. And these people who are not dead yet, but have drastically changed their behavior and their appetite, ultimately is more plausible since, neuroscientists can change behavior in mice and rats with different viral techniques.
Right. They're also very fast, which I think works in those movies because they're technically alive. They're not dead tissue that's rotting. They're functionally living tissue that can still move and
exactly. And then they get their nutrition and anything and stay alive by eating other humans.
Right. Which brings us back to kind of another classic trope of eating brains.
Ooh.
So aside from just the horror of, someone trying to eat your brain while you're alive, what is something that's really scary about eating brains that we can talk about?
Well, one thing that comes to mind is a story of a disease called Kuru.
Ooh.
And Kuru is a disease that is related to mad cow disease.
Yes, we have all heard of mad cow.
And so that was a huge scare in the early 2000s. That these cows were, acting kind of crazy, and they found out that there was a mutated protein that would infect the neurons and cause other proteins to be misfolded or mutated as well.
It's interesting because you don't tend to think of like a protein as being infectious. And this is something really particular that, like you said, it's a mutated protein where it's what we'd call misfolded. So the shape of it is different than what it normally is. And when it's ingested and it gets in contact with the nervous system, it then can make other proteins change their shape.
Yes.
And that's how it's infectious, is that it will then change the proteins in whichever body has ingested it.
Yeah, and so there's a human disease called Creutzfeldt-Jakob disease that is just a spontaneous mutation of one protein that will ultimately change all of its neighboring proteins or the similar neighboring proteins into a infectious or a pathogenic protein.
Right. We call these prion diseases.
Yes. And so these prions or misfolded proteins will then go and destroy the neurons in the brain, ultimately causing some tremors and cognitive deficits or losing your memory or pretty much everything that your body controls.
Right. And so with mad cow disease, the cows were actually getting these prion diseases, unfortunately, because of bad farming practices.
Exactly.
Where they were ingesting the tissue of nervous systems of, I guess, other cows.
Of other cows, yeah.
Because of trying to, I guess, waste not, want not, for lack of a better way of saying it.
Yeah.
But it was a terrible practice because then you get these infectious prions, and each cow that would get it could then also be spreading, potentially if those sick cows were then also unfortunately fed to other cows. It just kept propagating and spreading.
Yes.
We should say it wasn't intentional that they were, spreading these prion diseases. And unfortunately, this prion disease could be transmitted to humans. When humans ate the beef that was tainted, they could get very sick.
Especially if the beef had remnants of neurological tissue,
right?
Then it was a little bit easier to be spread. But this kind of brings us back to humans eating meat and humans eating nervous tissue. Is why Kuru is so interesting. Is because there is this very small tribe in Papua New Guinea that had a ceremonial practice of eating the brains of their elders. And they've been doing this for a very long time. And the brains were kind of a way to pass down, wisdom and knowledge from their elders.
Right. They weren't being like cannibal zombies. It was a way of respecting their dead. Unfortunately,
one of the elders had Creutzfeldt-Jakob disease. And like I said, this was a spontaneous mutation in this person. And when that one person had Creutzfeldt-Jakob disease and they passed away, the rest of their family members honored their body by eating their brains, which ultimately caused them to inherit the disease that was the misfolded protein.
Right. So what has been described as Kuru is a prion disease. And unfortunately, Kuru spread amongst this population because they were eating the nervous tissue of people who had this prion disease.
Exactly. And it's interesting because this tribe called the Four people of Papua New Guinea, they have their own language, and their word kuria is also translated in English to shake. And so the people who would get Kuru would have tremors. And so they called this kind of a shaking disease. And that was only what they were able to describe it until doctors came through and knew that this was a neurological disorder.
Right. And that's similar to how the prion disease would manifest in mad cow. So these prion diseases would go and you get these misfolded proteins building up, and basically it causes deterioration of the nervous system. It makes the neurons so sick that they start to misfunction and eventually die. And that's unfortunately what happened to these people that had Kuru.
Which is extremely scary.
It is.
And is kind of the cutting edge of neuroscience today, is trying to figure out what diseases that we currently study are similar to prion diseases. So some researchers believe Alzheimer's and Parkinson's are prion-like, to where they have a misfolded protein that ultimately causes more misfolding of proteins down the line and ends up killing subsets of neurons, which have similar symptoms to Kuru.
Yeah, with Parkinson's, people end up with tremors. And certainly with Alzheimer's, you can get some peripheral effects, but you generally think of memory deficits as the brain tissue starts to die. That's pretty scary to think about.
Oh, yeah, definitely scary.
Makes you feel a little better about watching scary zombie movies that are definitely not real.
Exactly. And I think that's part of the reason why we feel so good when we watch some things, because we know that at the end of it, we're okay. We're having fun, and let's go watch another zombie movie.
Yeah, then we'll go out to the shed and play video games with our zombie friend.
Exactly.
So you can find us on Facebook and Instagram at ascend.program, and on Twitter at program_ascend. And we also have a TikTok where you can see some videos of neurons and brains and some activities from the Ascend Neuro Explorers events.
And feel free to send us any questions and comments on social media or email us at ascendneuro@gmail.com. We'd love to hear from you.